The first and foremost way of checking whether data are entered properly, missing cases are treated or not, just run a descriptive statistics. To run a descriptive statistics, on the menu, you can see tab, go to analyze and select descriptive statistics. In that, there is a descriptives. And select all the 30 items from A1 to A30. We have been selected all the items and say OK. The moment you say OK, the result is generated. You can see this is the item, this is a n, number of observation, minimum, maximum, then we can say mean and standard deviation. Now in this case, if you see all the n's are 310, mean the complete cases is 310, and minimum is range between 1 to 9, and this is a 10 point, it is a 9-point scale actually. Then somewhere you can see -1 is given. Actually the scale should start from minimum from 1, not from -1. The reason for -1 is in this data set, the researcher used -1 as a missing cases. Sometimes a researcher used 999 as a missing cases. Some researcher use -1 as a missing cases. Now to just keep this -1 as a missing cases, we have to do a small things here. Let us go back to data set. So here under this missing, you can see the missing column, and we have to indicate, just go inside this none, select the none, inside it, you can see discrete missing values. Just we assume -1. The reason here is data entered -1 as a missing cases. If it is a 999 as a missing cases, we have to mention 999. Sometimes if 999 is a missing cases, we have to make a 999. Any number for the matter, maybe 11 or 0. Now once you say OK, now we should know which all the cases has got this kind of thing. For instance, if you see here, -1 meant for A6, A7, and it keep on goes. It keep on goes like that. So one easiest way is we can copy this, right click, copy, select all the items missing values, and right click, again paste. So this ensure that wherever -1 any of the items, that will consider as a missing case. Now to check whether it is treating -1 as a missing cases or not, let us run once again descriptive statistics by choosing analyze, descriptive and say OK. So this time you can see output never reflect -1 because it is treated as a missing cases. And the value of mean surely will change compared to the last time. So most of the cases minimum is 1 or 2, maximum is 9, and mean is ranged between. Here for first item 7.71, 8.34, so on so. So now we learned how to treat the missing cases as a first job. Now we run the descriptive statistics as a second job. Now the next job is we have to conduct an EFA. So I just put the same thing in the form of PPT. So this is with the missing cases. Now this is after treatment of missing cases, the output has got changed. Now before we are getting into EFA, then just let us see what all the expected things should we do in EFA. As we are aware of, EFA is not done in a raw data. The raw data is converted into correlation matrix. On top of this correlation matrix, we have been running EFA mechanism. So normally the first step is we have to make a correlation matrix. So the expected correlation matrix is ranged between 0.2 to 0.60. If it is anything above 0.80, it is a big concern for us. Maybe the cases of multicollinearity or a lot of bias in the data. Even if the cases are below 0.10, means there is no much correlation among the matrix. So that first we have to understand that. And second thing is to determine number of factors. To determine number of factors, the eigenvalue should be greater than 1. By default in SPSS it is greater than 1. So before getting into EFA demo, let us understand what is the requirement in EFA. So one is correlation matrix. As we are aware of, EFA is working on correlation matrix than a raw data. As a first job, we have to convert a raw data into correlation matrix. On top of that, we have to apply statistics like eigenvalue, KMO, and estimation method, rotation method, etc. A correlation matrix is ranged between 0.20 to 0.60. That seems to be the ideal one. But anything above 0.80 or anything below 0.10, a bit concern. If it is above 0.80 or 0.90, there is a chance of multicollinearity issue. If it is very less figure like 0.10 or 0.05, there is not much correlation among the selected items for the EFA. That's one thing. And eigenvalue by default should be more than 1. Even if it is close to like 1, such as 0.9 or 0.980, still we can consider it as a for the further analysis. And KMO and Bartlett test of sphericity, which assess MSA, that is a measure of sampling adequacy, and Bartlett test assess the correlation structure is intact or not. Then further we can use a PCA or PAV or ML different estimation, and rotation method is the and factor score, and that is how the mechanism for EFA has to be done. Now going back to SPSS, now let us show the steps to compute a EFA in SPSS. So you can go to analyze. There is a button called dimension reduction, and you can see factor. Choose this and select all the items which is meant for analysis and drop it other side of the window. Now there are various buttons are there. Let us start with the descriptives. You can see there is a correlation matrix. You can select coefficient. It is nothing but it is generating correlation matrix. Next thing is KMO Bartlett test of sphericity. And say continue. Then go to extraction. In extraction, you can see by default most of the proprietary products such as SPSS, they keep PCA method. PCA method is there, and correlation matrix is the by default analyzing method. And if you want to get a scree plot, the scree plot is just to generate an eigenvalue in the form of graphical representation. And by default, you can see extraction based on eigenvalue is greater than 1. And if you want to decide number of factors, we can click this and say a number of factors, maybe 5 or 6, which are the figure. By ideal situation is first let us go by eigenvalue rather than fixing number of factors on our own. So here eigenvalue is greater than 1 by default. Continue. Then rotation method. By default it is none, but we can choose a varimax or you can choose a oblimin also. Varimax has got assumption that when there is no relationship existing between or among the factors, we can choose varimax. Otherwise, there is assumption there is a relationship existing between or among the factors, we can choose oblimin. So let us start with varimax and see how the output, then we'll move for oblimin also. Once you chose a varimax, click continue. Now will come back, we will just come to scores later on, because scores should be a last method, a last things to get the expected outcome. Let us move to option. In option, if you see the coefficient display format sort by size. This really helps us to sort by size in kind of descending order. The highest will go on the top, the lowest will come on the bottom. And suppress a small coefficient. The literature supports at least still 0.4 we can keep. In a very stringent we can keep 0.5, but still 0.4 is make more meaningful also. Continue. So let me recheck once again all the buttons. First we send the data to this window, then descriptives. In the descriptive we have chosen coefficient and KMO test. Then in the extraction method, by default it is a principal component. By default based on eigenvalue is greater than 1. and we have chosen screen plot just to show the eigenvalue in the form of graphical representation and said continue. In terms of rotation, we have chosen a varimax and say continue. Then come to option, we have chosen a sorted by size and suppress a small coefficient below point. Continue. Now we can say OK. Once you can say OK, we are getting the output in this format. So one easiest way is, let us select this output and copy and paste it in the Excel. Just for our discussion purpose. So we can see this is how the output as correlation matrix is generated. If you just examine very casually all this correlation score, the correlation scores are ranged between, some are very low, some are 0.2, 0.3, then some are 0.3, some are 0.2. So first we examine this correlation matrix. There is not much correlation which is a very high correlation like 0.8. We can't see such a correlation. But there are some weak correlation also there. So by and large it shows there is a very moderate correlation is established. That is what we understand from correlation matrix. The next thing is, let us move to KMO-Bartlett test. So as we test contents, Kaiser-Meyer-Oakland test, which is meant for a sampling measure of sampling adequacy, which is 0.853. Okay, which seems to be quite good, because what we expected is KMO should be greater than 0.5. What we got is 0.853. So we are more than a threshold value. Then in a Bartlett test of sphericity, the chi-square value is very high and significant value is just less than point. We can say p-value is less than 0.01. So it shows that correlation matrix is intact. Okay. If assume that if the significant value is more than 0.05, then we cannot proceed further for factor analysis. It's indicating there is no correlation is existing among the items selected for factor analysis. So there's two tests indicating, KMO indicating measure of sampling adequacy, Bartlett test of sphericity indicating the correlation matrix intact to further use for factor analysis. The next thing is communalities. A communalities is what is a contribution of each items for the factor analysis. Ideally, communality should be more than 0.5. That is what we expected. It should be more than 0.2 means 50%. Communalities never go more than 1. So it has to be a positive and it should be 50%. So if you see here communalities, in most of the cases, communalities are what we can say as communalities comes as it is almost 0.4. Most of the cases are more than 0.5. But if anything is less than 0.4, assume 0.3, 0.2, it is better to eliminate from the analysis. As of now, there is no such concern is happening here, so we can proceed further for the factor analysis. The next table is total variance explained. Now, before that, in total variance explained, it shows the first column is eigenvalue. You can see this eigenvalue contains still 7 factors. So it shows totally we have chosen 30 items. These 30 items we obtained almost 7 factors or 7 dimensions. And first factors contributing 24%, 16%, all the things. When converting this into variance, then this column is important for us. The first factor contributed 13%, second 12, then 10, and so on. So totally the cumulative variance percentage shows all these 7 factors contributed in terms of variance is 65%. Anything above 60% is most welcome and we can use further. So we also have more than threshold area, more than 60%. Now the next table here is what we call as component matrix. Component matrix may not quite useful for us. Only in terms of computing agent value and commonalities it may be useful. So let us skip that, then we'll go for most important table is rotated component matrix. So here you can see this is the table and there is no figure here. The reason here is we suppress the values which is less than 0.4. So there is a figure but we ask the SPSS to suppress. So in turn SPSS suppress these values. What is the advantage of doing this? Then we can come to know which items falls in which factors. It's very explicitly to understand this. For instance, in the factor 1, we can see all these 5 items loaded in factor 1, which including I will keep up the fashions in hair and clothing. I'll have people comment often about how attractive I look and I will achieve the look I have been after. My image will be the one others find appealing. So this all belongs to one factor. Now second factor if you see here, this all belongs to factor 2. And third factor, this all belongs to factor 3. If I just let us give a different color so easy to figure out which is factor 1, which is factor 2. So this is a factor 3 and this is a factor 4 and this is factor 5 and factor 6 and the last one variable has got only one factor. Now one thing we should understand, a factor analysis cannot attain the expected outcome in a single time analysis. It needs iteration by iteration to get the more expected outcome. So here one thing is at least a factor need more than 2 or 3 items to call as a factor. So first one has got good number of 5 items, another has got more than 5 items. Except the last one, if you see the last one, let us read the item name. A5 it says I will successfully hide the signs of aging, which is loaded. One is 0.467, other one is also 0.536. So this cross loading is equally loaded, one. And second concern here about it's only one item in one factor. Is it really we need this factor? So we have to take a call on this. One thing is go back and see the kind of data what we collected and who is the respondent for this. Because factor analysis is a theoretical technique. It's a data driven technique rather than theory technique. So let us go back to SPSS